Okay, our next talk is by Moss. Take it away, Moss.
Good morning, purplecon and those joining us by live stream. This morning, I'm going to talk about Docker and what containers are made of. So first of all, oh, come on, clicker, you worked like 10 seconds ago. Here we go. What are containers? So Alice Goldfuss has this really great talk called the Containers Operators Manual. It's about 40 minutes long, and I highly recommend that you go and watch that. And in it, she says that containers are processes born from tarballs, anchored to namespaces, and controlled by C groups. Now, there's quite a bit in there, but the point that I want to get across is that containers are made up of a bunch of native Linux features stapled together. So rather than being magic boxes, containers are standing on the shoulders of giants to make up their abstractions. And if you're attending KiwiCon tomorrow, you'll hear about the regrets of making Docker and setting up those abstractions from Jess Frizzell. Incidentally, Alice Goldfuss and Jess Frizzell are brilliant people to follow if you want to learn more about the whole Docker container ecosystem and the travels that are happening there. But today, we're going to talk about these abstractions as our friends. We're going to be dealing with Docker pull, Docker push, Docker build, Docker run, because we actually want to run containers, and Docker compose up, which helps us sort of mash two containers together and have them come up as a service. So these abstractions can help us get working now, but as we want to operate software, we'd want to continue learning about them, learning about what these abstractions are built upon, because when you're operating software, you really want to know where your abstractions are, because they're where all the wonderful and beautiful problems of operating software are going to come from. So we're going to work with an example today as we go through and talk around how we can be secure with containers, and all good code needs a good problem. Now on the purplecon website, there was a button that you could click and you would get limes, and you could get a lot of limes because they were stored in local storage. So if you really wanted to, you could have 1,337 limes, to pick a number out of thin air. It's definitely hacks, but it's okay. So let's solve that people have the ability to really easily say how many limes they have by uploading the limes to the cloud. So I went around and looked for a service that would help me upload limes to the cloud. And I found out that Redis has this really useful feature called inc. It means increment, but basically you tell Redis that I want one more of a thing, and it gives you one more of a thing. And if 30 people come up and say they want one more of a thing at the same moment, it goes, okay, cool, I have 30 more of the thing. And when I was submitting this talk, I pulled the container name out of thin air to put in my talk abstract. I picked Redis. Then once I picked the problem, it turned out Redis solved my problem, which is probably why it's about the 4th most popular container on Docker Hub. So try.redis.io is a wonderful website that lets you just connect to a Redis server and play around. So that's how I learned out that this solved my problem. But then I wanted to be able to get it onto my laptop and start developing with it. So I went to Docker Hub, and as I said, Redis is the 4th most popular container there. So I read its README, and it says, well, you can just run Docker run some Redis, and it will run Redis for you. And that output a hash into my command line. And I was like, oh, cool. So, okay, so what this means is that Docker's running a Redis somewhere in the background. But how do I connect to it? So I read further down the README of Redis, and it says, you then run this other command, and then that will give you the Redis CLI connected to your Docker container. I was like, awesome, I am up and running and incrementing limes. So if I want to wrap this as a cloud service for other people, I can't really tell them to go to Redis and increment their own limes. So I'm going to have to reach for some familiar tooling for me. For me, Node is particular familiar tooling. So I grab in my friends Express and Redis, and then I'm able to write myself a little service that helps create limes. Now, the next slide that I'm going to show you is kind of a prototype of what that looks like. As I was building this, kind of my CI pipeline and just getting it built went kind of very red and green, and here's a dog knocking over a pyramid. That's kind of what it felt like getting this to work. But basically, we tell Express that when somebody says that they want to put some limes, we'll go to Redis, we'll increment the limes. This is our only example to error checking in our minimum viable product, which is if redis doesn't get back to us, just say we have no limes, and then return like a little JSON blob that says, hey, you have this many limes. So now we have a very simple service that allows us to get limes, which tells you how many limes you have, put limes, which puts another lime in there, and post limes. You can't post limes. Do not put limes in the post. And in researching for this talk, I found out that lots of people like giving their dogs citrus fruits and then filming their reaction to it on the internet. So now we have our kind of service, and we're allowing the puppies on the internet to play with the limes. But what we've got is we've got a Docker container Redis, and then I've got a node service. So now I kind of want to combine them together. So I go ahead and Google, how do I Docker a node app? And there's about 4 or 5 different blog posts in the first page of Google results. And you kind of follow them, and you end up writing something a little bit like this. Once again, this slide is the final version that finally worked. It took me quite a few iterations to go, oh, okay, when I run node, I have to install the latest version so I can run that command. Oh, this is how the from commands work, that sort of thing. There's a Git repository that shows you all the wonderful steps that I took along the way to get this up and running. So now we have our node app in a Docker file. And then if you try and run it alongside the other Redis thing that you have in Docker, everything fails to work because then you need to learn around Docker networking. But that's where Docker Compose comes in. You just tell it, hey, I have these 2 kind of containers. One of them is my app. It is limes, and it depends upon Redis. And Redis is this thing. Go and get me Redis latest from the internet, please. And so now you have a very simple Lime cloud service. You've kind of got the first part of how to draw an owl. You have 2 circles that sit next to each other. So inevitably, in the software business, when you've built a really quick and dirty minimum viable product that has no security, no testing, no nothing, and you show it to somebody who's a stakeholder who's interested in solving their problems, they're like, cool, put it in production. And you're like, but I've drawn 2 circles, and the production system is a whole owl, and I haven't learned how to draw an owl yet. And if you go, well, I want to talk to a security person first, and you tell them, oh, I'm using a public Docker container, they go, well, no, don't. Why would you do that? Please don't do that. And if we remember back to Serena's talk, we'd be sort of going, well, now you've got to reinvent the world and learn how to fully draw in an owl. So let's go on the history computer lesson to learn why public Docker containers aren't a good idea. And then let's go on a little bit of a journey to work out how we can make some small steps to improve that. So back in 1984, there was a paper called Reflection on Trusting Trust by Ken Thompson. Now, Ken Thompson, if you look him up on Wikipedia, has been involved in a great many of things, but probably the scariest thing he's ever done is this paper. And it starts with kind of, to what extent should one trust a statement that the program is free of Trojan horses, that it is free of malicious intent? Perhaps it is more important to trust the people who wrote the software. So we're going to step through the kind of steps that build up this thesis. Step 1, programs can write programs. Most modern day programming we do in a language that we then ask a compiler or an interpreter to run. And there's also a really neat class of programs called quines, which are programs that output what the program is. And kind of people make these in every language that's possible, and it's kind of a fun, neat little trick. But this brings us to point 2. The C compiler is written in C. Most compilers for languages nowadays end up being written in themselves, which actually starts an interesting problem. We're like, well, how do you get the first version of the compiler? And there's this kind of bootstrapping process, and we'll come back to that thought. But here comes the really insidious part. If you have the source to a compiler, you can modify the compiler to pattern match on programs and deliberately alter them. So in 1984, Ken Thompson planted a bug in a C compiler that would match if you were trying to compile the Unix login command. And what this replacement code would do is it would miscompile the login command so you would accept a particular known password. So if you went and compiled login, you'd do it with your nice clean source code, and you'd get out a login command that did something quite malicious. But hopefully back then you'd then look at the source code to your compiler and go, wait, my compiler's doing something really, really odd. But here's where the terrible inception noise part comes in. We can modify a compiler to deliberately alter programs, including the compiler that compiles the compiler. So rather than just having a malicious compiler for the login, we write a malicious compiler that compiles a compiler that will miscompile the Unix login command. And at this point, everybody is very scared of any software that they didn't build themselves. The moral of the story is you can't trust code you didn't build yourself. And back in 1984, this was a particularly strong moral, and people would build their own software from scratch. But nowadays, we don't often do that. But public Docker containers are definitely code we didn't build ourselves, and that's still quite scary. So the typical advice, if you're using public Docker containers, is to stop and build them yourselves. So stop the minimal viable thing that you've just got working and go and learn a complete other series of skills to build up a Docker container from scratch. So we're basically telling people, in the words of Carl Sagan, that if you want to make an apple pie from scratch, you must first invent the universe. And we really don't want to have to go back and invent the entire universe. So what can we do to progressively build up trust in containers while not stopping the world to rebuild from scratch? Well, let's watch this dog sneak up on another dog and talk around what we can do here. So if we introduce a continuous integration pipeline, we can start making very small steps towards trusting our containers. We'll watch this dog sneak up once again. So if we take a public Docker container and wrap it in our own sort of pipeline of our own kind of build steps, we can start to really build up trust in what's going on there. And how do we do this? Well, let's watch the dog again. This is the pause slide, the dog. Yep. Okay, and back to our regularly scheduled programming. So we can write a very, very simple Docker file. This Docker file says from redis latest, and that's all it says. There's only one line in the file. And what this then allows me to do is I can now build my own redis. I can say I want to build purplecon redis production using that Docker file, which is in the app services redis folder. And what does this give me? Well, this gives me an image that's kind of under my control, and it allows me to actually change it. And it allows me to start at the start of a pipeline. And I can add services to that. So we're going to walk through developing a little pipeline and adding some things that will help us gain trust in our Docker containers. First of all, there's a really great Google open source tool that's called Container Diff. It does what it says on the tin. You give it 2 different containers, and it tells you what's different about them. There's a tool called inspec. It is kind of compliance as code tooling. You can point it towards a Docker container, and it has a whole bunch of things that you can write that are sort of like, well, what does it do? What ports does it have open? That sort of thing. And then, because Docker containers typically bundle up a lot of operating system and dependencies and things, it's actually important to run a bit of a vulnerability scanner there. Anchor or Clear are kind of the pretty good ones that I would recommend. So let's look at the CI pipeline. Once again, I reached for a pretty familiar tool, also one that's free if you have an open source GitHub repository, and went with Circle CI. This allows me to build up little different containers, and the important thing about Circle CI is that when I'm writing this, I'm just writing like Docker pull, Docker build, like I'm writing commands in there. So build redis is our sort of, back here, it's our Docker build. And in diff redis step there, we're just going to run container diff. We're going to run it with our little local version of Redis that we've built. We're going to compare it against one that I previously built and tagged in core production, and it's just going to tell me nothing is different between those, because at the moment I haven't changed anything. I use container diff as a signal that tells me if something has changed, and that's particularly useful if I'm relying on public Docker containers, because somebody upstream might be changing something, and if I'm just straight using the public Docker container, I'm not going to know that. This is going to help me know that. Inspec as compliance as code can do a lot of wonderful things. There's a lot of very interesting kind of security benchmark profiles that are out there that you can just run against your Docker containers. But the first thing that I always like to do is my Docker container gives me a service, and I just want to make sure that it's continually giving me that service as I try and change it. So this execs against my Docker container, and it just goes, well, do you have the Redis CLI in you? And if I run ping, do you return back pong? It goes, yep, cool, everything's successful, great. So I have a very minimal kind of compliance as code step in there, and I can expand that as necessary. And then we run our vulnerability scanner, and it tells us, oh, there's a bit of vulnerabilities in there. So let's make our first change. So the latest tag in Docker is not your friend. It is not what it seems. The latest tag isn't the latest build. What it is, in fact, is it's anytime somebody's built something that didn't have a tag. So this has bit me and other people so many times because it breaks people's just casual expectation of what's going on, that it's much easier to just not use latest at all. So we're going to make our first change through our CI pipeline and see what happens. So from our original Docker file, we're going to change from Redis latest to a very specific version of the public Redis Docker container. And we're going to see what happens when you run that through the pipeline. So the container diff's going to tell me that there was a difference, which is good because I was expecting that. If there wasn't a difference, I would have been quite worried. Our compliance as code is telling me that, yep, that is still providing you Redis. Good, that's great. That's what I expected. And my vulnerability scanning, I'm actually using quay.io as a Docker repository here to do that for me, rather than set up my own vulnerability scanner. Because I'm using public containers, they're doing this for me for free. If I was using private containers for work, they'd be charging me about $3 a month per repository to do this. But that actually tells me that my previous container had a bunch of known vulnerabilities, and this one doesn't, which is a signal. It doesn't necessarily mean it's secure, it's great, everything's good. It just means it doesn't have any known CVEs. So in my production system, how do I use this? Well, from our Docker Compose before, all I'm doing is changing which image I am pulling from. And if I have a stable tag like purplecon Redis productions, my CI pipeline can continue to make changes to that Docker image. I can take it on a journey from Redis latest to MOSNZ purplecon Redis stage 6 with a little bit of diffing, compliance as code, and vulnerability scanning along the way. I'm very happy with this dog GIF. I was so happy when I found it for the last slide of this talk. There's a GitHub repository, a Circle CI workflow, and a quay.io repository that show all the working behind the pipeline that I've built in this talk. You can see how wonderfully it Christmas treed as I fix things. And the journey that we've gone on has taken a public Docker container to a build pipeline that gives us a little bit more trust. We haven't rebuilt the universe from scratch yet, but if we wanted to continue that work and build our own containers, we've had a really good first steps to be able to do so. I've been Moss, thank you, and please continue to have a whimsically secure day.